Hey everyone, and thank you for joining us today. I am Jennifer Joyce. I'm the Regional Vice President for Sales for the West here at Condusiv Technologies. And I've got with me today my partner in crime, Howard Butler, Senior Director of Systems Engineering. Just a quick introduction for Howard. He is a 30-plus year veteran of Condusiv. He is a complete expert in the inner workings of the Windows operating system, so I think you're really going to enjoy hearing from him today. And Howard, thank you for joining us.
Hey, thanks very much, Jennifer. Glad to be here. And everyone, hey, don't let Jennifer's title fool you. She's been with the company for over a decade now and is quite technical as well. One quick housekeeping item, though, I did want to mention, Jennifer, is that this is meant to be an interactive kind of webcast. So guys, please feel free to drop in your questions in the Q&A section, and we'll answer them as we go along, or at the very least, we'll answer them towards the end of the session here today. So Jennifer, again, thank you very much for inviting me.
Great. Hey, thank you so much, Howard. Okay, we're going to jump in real quick, everyone, and just another housekeeping item. What I'm going to do is we've organized this into two parts today. The first section, I guess we could kind of call it an executive briefing. The second section will be our technical briefing. So if for some reason you have to drop off and you don't want to stick around for the technical briefing, we will send a recording, but let's get right into it for you. So what we're really looking at today is just our throughputs and our speeds within the Windows operating system, and just a little bit of why we have some expertise to be able to talk about this in this particular field, and just a little bit of who we are so you know who you're talking with today. We are a 39-year-old software company. We've been around for a really long time, and I just want to call out a couple of what I like to call our Scout badges. Specifically, we are a Microsoft Gold partner. We have been since day one of their partner program. Just one of a handful of companies in the world that have ever had access to the operating system source code outside of Microsoft proper. And in fact, Howard was on our team with that access. So he's got quite a lot of knowledge about how the inner workings go, and that you're going to see the relevancy of that as we go into today's content. We're going to jump right in. So we're going to focus today primarily on VDI, but I did want to just mention that everything we're going to be talking about today really focuses on the Windows operating system, and it is relevant to both server and VDI environments. And what we're focused on is literally transforming I/O, how to make I/O more efficient, really kind of how to hack the Windows operating system to increase and accelerate throughput on the hardware that you already have. Okay, so what I've got up here real quick just to get us into the conversation is because of VDI accelerating so much in the last few months with everything that's been going on, just kind of wanted to talk about the S-curve of growth adoption of VDI. So we all know what an S-curve is. It's kind of the adoption of products, and just a little humor here. Products go on the decline and they go completely out of vogue after having been completely popular. Horse and buggy, Model T Fords, and some other technology that, you know, we don't find around very much anymore. And on the way out, spinning disks, we still have a lot of them out there, but SSD adoption is probably in the 70, 80, 90% range. Spinning disks are definitely on their way out. The other area that we are seeing a lot of maturity in right now that's very common, tiered storage. A lot of individual compute is still out there. All-flash storage, hyper-converged is really coming up in center. And of course, virtualization is at a 99% adoption rate, especially on the server side. Not so much on the client side. It's getting there though. And in the rapid growth is, of course, cloud and VDI and hyper-converged infrastructures. So what we're talking about today really is focusing on that VDI adoption, because it's really was kind of at a less favorable area. It was really a challenge to implement, but it really has gone into a lot of acceleration. We've been getting a lot of calls about it. So we're just going to talk a little bit about some of the benefits and barriers to VDI adoption that we've been hearing from folks. Of course, with benefits, we've got mobility, productivity, improved data security, just streamlining the management of IT, and just having a central image to manage. So there's a lot of benefits there, and of course, low maintenance endpoints. You get to the zero client environment. Barriers that we've been hearing from folks, and Howard and I have a chance to talk with a lot of people about this. They've been telling us it's complex, it's expensive. A lot of times, it's a lot more expensive to support the host footprint and the virtualization costs over having a traditional desktop sitting on someone's desk for 3 to 5 years or longer. Also difficult to manage and deploy and requires quite a bit of in-house expertise to pull it off well. We've had a lot of people try it, pull back from it, try it again, pull back from it, but they're now getting into a position where they really want to make it work. Another barrier is that the end user experience is often perceived or is actually better on endpoints. We get a lot of feedback on that as well. So TCO, just total cost of ownership, just being a lot higher on the virtual space for VDI. So the shifting though, and really the shift has gotten to do with these major life events that our economy is going through and that our society is going through, where telecommuting is going to be normalizing. The interesting thing about this is that we're going to be seeing pressure, and we already are seeing pressure from both sides, both the telecommuters who are new to telecommuting going, hey, I kind of like not having to commute, I'm getting more done. And we're going to be seeing from the corporate side. In fact, I just saw I think it was Barclays put an article out just a couple weeks ago saying, hey, we anticipate not having the traditional brick and mortar presence in our downtown hubs any longer in these huge towers we've been in. So, you know, they're realizing the TCO cost of people don't really have to be here. We can get rid of the real estate. And now this virtualized remote workforce makes a lot of sense financially. So really the scales tipped very quickly. So what we want to do is really look at what can we do to optimize the performance side of this through a non-hardware approach, through optimizing the actual image. Now, this is really interesting because one of our server customers, they're deployed on their entire enterprise, around 400 servers, and they were struggling with their VDI. They were looking at having to cut density in half as they were upgrading to Windows 10 and a couple of other things that had happened in their environment as well. And so they went to their tier 1 application provider and asked for some recommendations of how they could avoid adding more hardware, how they could get the throughput, back-end throughput numbers up without hardware upgrades. Ironically, the answer they got back was add more hardware. Very helpful. The other answer they got back was assess everything in the image. And my client was left a little bit scratching his head going, well, okay, well, what happens after I assess everything in the image? I've already got everything in the image I think I need. Are you recommending that I strip things out of the image? I've already got what I want in there. And also, you know, I can't really go in and recode these applications. They're third-party stack. So what does reassessing everything I have in the image do for me? And as we were kind of laughing about the recommendations he got, I kind of had, you know, a facepalm moment. And I said, well, you know what, the Windows OS is in the image. And he got it immediately. He started laughing because on their server environment, we have already demonstrated with our Velocity software in their environment that we accelerated throughput and performance by 30 to 40%. And we're sitting here just dealing with another Windows OS with the Windows 10 environment. And so we kind of got a good chuckle out of that and started going down that path of Velocity for their VDI environment because it made a lot of sense. So we wanted to get right into the use cases with you guys in the executive summary period portion of this. We want to really show you what Velocity is made of, what it can do, so that you can really get into that Windows OS experience and really figure out how to hack your performance right at the source where the data sits, rather than trying to go in and really, I guess, overwhelm performance with hardware. So the thing is we already have a lot of hardware in the environment. We're already upgraded. We've already done everything we can there. So what else can we do? We are leaving performance on the table. So we've got 5 real world use cases to show you, and I'm going to jump into the first one right now. Now, this is a chart. We're trying to cover, you know, all of the different VDI platforms that you could work with. I know we'll probably miss some, but we'll go with the first one here. This is a chart of some of the testing results that came out of our Citrix Ready certification. Now, these are iometer benchmarks. They were run on a Windows 10 system running Citrix XenDesktop VDA, both with and without Condusiv's Velocity product running on it. Now, with Velocity, transaction rates increased by over 90%. And also with Velocity, running the exact same benchmarks with the exact same amount of time, the amount of work that we were able to accomplish on that system went up from 169 gigs to 273 gigs. So I'm going to repeat that. That test, the exact same period of time, with the exact same workload being thrown at the exact same system, we were able to actually transact 60% more work in the same period of time. And that is an indication of that throughput increase that really just popped it. The only change was that we added Velocity. So it was on the hardware that was already there. Now, let's get into what I like to call the 2 IO fallacies, right? There are two major myths, IO myths, that I want to touch on real quick. And this again goes back to addressing that the problem isn't the hardware, but there is a different way to look at this, a different perspective or a different prism to look at this through. And I want to discuss the first one. The first one is the IOPS myth, okay? Now, the IOPS myth is, I'm going to just explain this with a quick analogy. Now, I'm 5'3", and I own my height. I wear flats, I'm proud of it. I walk into a room, and let's say that this room has 20-foot ceilings, and it's really crowded. I literally cannot walk through the room without, rubbing shoulders and bumping elbows, literally. And someone hands me a message and says, your mission, should you choose to accept it, is to walk from one side of the room to the other without touching anybody else. This message will self-destruct in 5 seconds, right? So I'm not actually going to be able to do that. And so I might eye that 15 feet of space above me, trying to think maybe I could do a Mission Impossible harness thing and get across the room through the air, but I know that's not going to happen. What I have to focus on is the 5 to 6 feet of space that everybody else is standing in. Now, the reason for this analogy is let's equate that to IOPS ratings in the real world. So let's say you've got an all-flash SAN sitting there, it's got 100,000 IOPS rating. We know that we're not using that 100,000 IOPS. In fact, we're probably using 3,000, maybe on really heavy workloads, we're bursting up to 9 at occasion, right? So let's say we're using, let's be generous, let's say we're using 10% of our total IOPS capacity at max peaks. The 90% that we're not using is unimportant, and that's the IOPS myth, right? We don't want to focus on that portion that isn't actually being used. So the idea that I already have more than enough IOPS to handle the workload, we're not using those IOPS. We're just going to focus on the 10% or less that we're actually using. And the thing is that 10% is going 30 to 40% slower than it should be. And we get this false sense of security that our performance is at maximum throughput because we have the high IOPS ratings. And those two conclusions are not actually, they don't follow each other. Now, something that I really want to get into here is how do we hack the Windows operating system to fix this problem that we are in fact losing 30 to 40% out of this hardware investment that we've made? Well, the first thing I want to talk about is the nature of the I/O. When Windows issues I/O, it issues it in a split and small random I/O pattern. And that is just sucking the performance out of the throughput, the life out of the throughput. One thing to keep in mind is that sequential I/O will always outperform random I/O, okay? Now, the truth of the matter is that and I just touched on this, the only small percentage of the I/O capacity is being used at any one given time, and that gives us that false sense of security. So with Velocity, we get the optimization work done up at the Windows operating system level, and all of that spare capacity that isn't being used doesn't matter. We're going to take the capacity that is being used and really maximize the throughput on it. Now I'm going to touch on the second I/O fallacy or myth, and that is the I/O response time fallacy. Okay, now this is really interesting because I/O response time can be really misleading. Now the myth is that faster I/O response time is better. Okay, stay with me here on this one. The reality is that a smaller I/O transfers faster than a bigger I/O. So if you've got an I/O with 4 KB of payload, or you've got an I/O with 64 K of payload, the 4K I/O is going to simply go faster. It's just mechanics, right? There's something else it doesn't take into account. It doesn't take into account, is the I/O being issued in a split manner, split I/O, or is it contiguous? This also doesn't take into account, is the I/O randomized or is it sequential? And as I touched on just on the previous slide, it matters. So larger, contiguous, sequential I/O as the format of data transfers 30 to 40% faster than small, split, random I/O. It makes a difference. So the truth of the matter is that the individual I/O response time of each I/O has been over-prioritized in the performance analysis equation. And what we really want to look at is how is the data structured when it's issued from the Windows operating system, because that's going to have the biggest impact on your performance on the hardware you already have. So it's a really interesting way to look at it. And so So Howard, before we go into the technical portion where we talk about these two Windows hacks of how do we recover that 30 to 40% of performance at a software only solution at the Windows OS logical layer and maximize the performance on the hardware people already own, I wanted to ask you to take us through these other real world use cases where we actually deployed Velocity to live production workloads and did a lot of benchmarking with various tools. So Howard, if I could turn it over to you for these use cases, that would be fantastic.
All right, well, thanks very much, Jennifer. So guys, let's take a quick look at what Jennifer was talking about in terms of this IO transformation and what our software products can do to assist them. Okay, we're going to go through these slides rather quickly, so I don't want to bore you with a lot of details, but I do want to emphasize, buckle up and pay attention here, okay, because we're going to go through this rather quickly. The nice thing here is that we validate these type of measurements with third-party tools that you probably already have in your environment. For example, like VROPS, which is what we used at this particular case, at this particular hospital. The orange lines are with velocity, and as you can see, there's a pretty nice trend of improvement in write requests per second, okay? But if we move on to the next slide, Jennifer, and we take a look at latency, we go, huh? What's up with this write latency? I mean, if you were to consider that this was the only metric you looked at, you would probably walk away in thinking that velocity was kind of slowing things down. But this actually ties back to what Jennifer was talking about in terms of IO response time being a myth. So let's see what actually really happens in the next metric. So now look at this. The write rate has just jumped through the roof once velocity was enabled. So Jennifer, I kind of want to go back a slide for a second. And when we're looking at that write latency, sometimes the latency is up to 3 times longer. And if you go back to the write rate, how much work are you actually getting accomplished here? We can see that, you know, the write rates have improved anywhere from 2 to 6 times. You know, and, you know, I think it's extremely important to focus on, you have these computer systems to do real productive work. And if you can get more work done without, you know, putting your response time completely upside down and still be able to get IOs done quickly, but have a much larger volume of data throughput, that's what's really going to translate into improved performance and ability to do useful work. So let's now take a look at what happens on the read side of things. And we notice something very similar here. The read latency, it appears that it's gotten a little bit longer. And if we move on to the next slide, we can kind of see here that the read rate is just killing it. It's off the charts. So you got to step back for a second, and what do you really want from your computer systems? And that is the ability to do more useful work for the users and for those applications. Now, let me throw in one other metric here for this use case, and that is disk usage. And I think this picture kind of speaks for itself. But let me just kind of mention, it isn't about the end user experience. Now, of course, it usually does come down to that, but you have to kind of, you know, step back for a moment and think with the idea, why do you currently have, for example, in this particular case, why would one have the VDI density count set to where it's currently at today? And that is because of user experience. But when we install Velocity, it would not be valid to go back and ask the users, hey, did you notice anything being faster? It's because your systems were already optimized for the workload. And with Velocity, you can now scale back up the density or increase the number of VDI systems and still keep response time and throughput at its optimum. And then Jennifer, I do want to kind of move on and I just want to touch on one more thing here, and that is about how important this concept of IO transformation really is. I mean, most people tend to think as IOs only at the storage level. But where does the IO begin its journey? It's within the application, handing it off to Windows. And if Windows is breaking up those IO requests into many smaller, more random requests, it's increasing the amount of IO traffic that your storage system has to deal with. So if we just take a high look at this, or a high level look, to kind of sum it up, the bottom part of this graphic is what we really want Windows to be able to do, to issue large, more sequential, contiguous type of IOs. And this is going to be the key in being able to get that 30 to 40% or even more amount of throughput with your existing hardware platform. So your hardware should be able to perform faster, but the way Windows is handling the data logically, it's like Windows has got its foot on the brake pedal of this fancy, Ferrari or Maserati you have, and think of velocity as being the enabler to press down hard on that accelerator and get more work done. So now, let's jump ahead and take a look at our third use case. I'm not going to spend a lot of time here, but this is another Horizon environment, and they're using a pure all-flash type of storage array. And again, tested and data was collected using VROMs. And the numbers are, from a Fortune 500 company. In fact, it's one of those household name cable companies that we're probably all familiar with. But these are a sampling from their call center. So when we look at the disk usage rate, we can see that it's significantly better, more than double in most cases. But if we jump to the next slide here, Jennifer, and we observe and look at the number of commands per second, it's improved significantly, more than double in most cases. And I think that's, kind of puts things in perspective here. And here we go again with the average number of write requests. We can see that across the board, every system has realized a significant increase in productivity or activity in the environment. And then if we take a look at the write rate measured in kilobytes per second, this shows the average number of kilobytes written to the disk each second. And we can see again across the board, every system has realized a significant increase in activity. And this would be tied back to velocity transforming those small split random IOs and helping Windows create larger, contiguous, and more sequential data streams. And then, let's just take a look at the read rate. Same storyline here. We can see that the average number of kilobytes per second has increased significantly. Now, I do have two more cases I want to touch upon, and then we'll kind of jump back into more of the technical briefing and technology understanding. So we just wrapped this one up not that long ago. In fact, it's one of our partners that did this POC and then brought the results back to their customer. And the conclusion was that the net result is that the Velocity product would enable them to run double, let me say that again, double the number of VDI clients in their environment, and possibly 5 times more if they were just to add a little bit more extra DRAM to the host or individual guest VMs. And that's significantly much better than having to go and purchase more hosts and spread the workload out across more physical hardware. So let's take a look at the real numbers on the next slide. And we can kind of see here we have near identical number of systems. And we did notice that there was a decrease in CPU usage. And that's primarily attributed to a greater amount of activity that's occurring. Memory usage did go up, but this was free, idle, unused memory that would have been wasted anyway. So it's kind of a free commodity, a free resource that's available out there for us to utilize and help improve the throughput productivity in the environment. That lets us dynamically use a portion of the memory to kind of get things moving there. resulting in far less I/O traffic going across from the guest VM to the hypervisor and host, perhaps out across the network to an appliance, to the storage, and so forth. If we can help Windows issue fewer I/Os, you're going to be able to utilize and have more productivity in the environment with the same hardware. And if we take a look at this last fifth case here, we can kind of see this was tested in a load-balanced Citrix terminal server environment. The customer tested this, collected data using vSphere, sent the data back to us, and the conclusion they came to was that they would have a 32% improvement in reads and an 18% improvement on writes just by using velocity. So I think that kind of sums up the use cases, and I hope this information has been really useful to everybody. So Jennifer, I'm going to kind of turn the conversation back over to you now.
Okay, great. Thank you very much, Howard, for taking everyone through that data. So just to kind of wrap up the executive, so just to kind of wrap up the executive summary portion of this, you know, we basically are focused on improving the throughput, 30 to 40%, and this results in a lot of different things. Obviously, increasing the density on VDI, reducing timeouts and crashes, especially in the SQL environment. Pretty much any application running on Windows, whether it's server or client OS, is going to be improved. And one of the things we hear the most is extending the hardware cycle. We get many of our clients who've been with us for a very long time are keeping their hardware, their SAN and whatnot, 7+ years. It's pretty incredible, actually. So, you know, there's a lot of benefits that we could, you know, we've got 20+ published case studies on our website. We've got these quotes here, which I'm not going to hop into right now. You'll get a copy of the slide deck. But a lot of people have a lot of good things to say about their experience with our software. Now, how do you get your hands on it? How do you test it? We'll cover that real quick, and then we'll get into the technical side of exactly how we hack the Windows operating system to make this magic happen. First, we would invite you to schedule a call with one of our engineers and or sales consultants and assess your environment to see if it's a good fit in the first place. And then we would conduct a free proof of concept, you know, give you guys a 30-day trial to test it and kick the tires. You can deploy it to as many systems as you want. And then we would help you quantify and write a business case for getting it approved. So that is kind of what we've got on the executive side. Now we're going to go to the technical briefing. If anyone does need to drop off, the technical briefing is not going to be that long. What we do is very straightforward and simple, but if you do have to drop off for any reason, we will send you a recording of the session. Okay, so let's jump right into it. Okay, so what we're looking at here is obviously a rudimentary extraction of a virtualized environment. I realize that this is pretty oversimplified as things go, but we're really looking at two severe I/O inefficiencies in the environment, and they're driven by the Windows behavior. This is what's creating that small, more fractured, more random I/O profile than what we need is the Windows I/O tax. This is actually how Windows is handling data and structuring data logically. And here's the thing, Windows is Windows is Windows. This is happening whether you're on a physical standalone server or piece of hardware, whether you're virtualized or whether you're in the cloud, even if it's a hyper-converged. None of the hardware that's housing the Windows operating system and the applications within Windows can overcome this. They are all affected by it. So it's a pretty serious performance issue that Windows introduces. And it gets compounded by what we call the Windows I/O blender effect. And this is when you have multiple VMs sharing the same hardware, the same environment, all vying and competing for those resources. And you've got all of them issuing small split random I/O, and that's creating that randomization pattern, adding that 30 to 40% latency that we were talking about. Now you can go ahead and just deploy to one VM or a small subsection of the environment, and you will certainly get some optimization benefit. But as you can see, this really highlights that I/O blender effect. You're still going to have all of this I/O pressure by the noisy neighbors. So what we really want to do and emphasize with the Velocity software is a universal deployment approach. So this is kind of the ideal state. And just a real quick example of this, we did a deployment, and it's a SQL Server use case. Did a deployment, the customer had 120 SQL servers sitting on 6 hosts. They had one of those servers supporting one customer they were missing a monthly SLA on, and it cost them $10,000 a month to miss that SLA. They had missed it every month for over a year. So this was a very expensive problem that had the attention of management. They asked us, could they deploy just to one server and get the result? And we said, probably not. Go ahead and try it if you'd like, but we're 99% certain that because of the IO blender effect and the density you have in that environment, you're not going to get the result, and that's what happened. So we worked with them to get their 10 busiest SQL servers out of that cluster the next month, and the next month was the first time they made that SLA in over a year, but they only made it by 3 minutes, which is not a very comfortable margin. The following month, velocity was removed. They missed the SLA by 5 minutes. And then the month after that, they put a velocity on all 120 servers, and they made the SLA by 17 minutes. Now, we asked them to go back and verify change control tickets that they had put in to make sure that we were the only major change being made over that 4-month process, and they confirmed and verified we were in fact the only major change being made during that period of time and the only thing that they could attribute to. They also verified, validated that their workloads were consistent across all of the samplings. So that's just a really good example of the IO blender effect and how by deploying velocity right inside each Windows OS and addressing the inefficiencies in the Windows OS itself is having that type of an effect. Okay, so velocity, real quick, is a 100% software solution. It installs right inside the Windows OS. And I think the most important part of this slide is that it's what I like to call the top of the stack. That means that we're hitting the optimization at the source. And that's very important that we address it at the source rather than the symptom. All right, and the other thing too is compatibility. So because we're nested right inside the Windows OS and we don't have to talk to anything else, including the hypervisor or the storage, everyone else is also compatible with Windows, we're good to go. We play nicely in the sandbox. Okay, so the two engines, the first hack for Windows is our write optimization engine called IntelliWrite. We'll talk a little bit more about that. And our second Windows hack is our read optimization engine, which is DRAM read caching. We also will touch briefly on the reporting and the manageability of the software. So let's jump right into the first Windows hack. So this is the write optimization called IntelliWrite. Now, Howard, I would like to cover this, but I think that you probably do it better justice than I will. Will you give us a couple minutes about the IntelliWrite engine and how we optimize and get rid of that small fractured IO and convert it into that large contiguous sequential IO?
Sure, my pleasure, Jennifer. So guys, when we're looking at this, Windows doesn't have any type of a crystal ball to look at in terms of recognizing how large a file is going to be, or even where the largest chunks of free space are at. Windows takes a very simple approach and just simply allocates or grabs the first available free space. So if your application is passing on an IO request and it wants to write a megabyte of data, and Windows goes and grabs the first available free space, if that first available free space is only 4 KB, it will write and allocate what it can into that 4 KB section of free space, send that IO request on down the wire, and then go and grab the next available free space. Well, what if it too is really tiny or small? It'll write what it can, send that IO down the line, and then go and grab the next available free space. So you can kind of see here, your application sends one IO, but Windows doesn't have the intelligence to recognize where are all the larger chunks of free space. So what we're able to provide to Windows is to tell Windows, hey, don't bother with allocating this tiny little segment of free space. Here's a large segment of free space that's ideal for the size of the file you're trying to create. And as a result, only one allocation, one IO has to be sent down the wire instead of all these tiny little ones. And the point here is that every IO request matters. Every IO request takes some amount of time. And so it's just a simple matter of mathematics of, do you want to do 1,000 individual tiny IOs at whatever your system's average IO response time is? Or do you just want to do one? Okay, and that's what adds up to the speed and improvements here.
And Howard, just a quick note, great explanation of that is that the reduction totals about 30%. So we can and we'll be able to show that in the UI when you do your evaluation, but you saw all of the third-party graphs and whatnot, but what this really means is that if it was going to take 100,000 IOs to write a gig of data, for example, this engine transforms that IO so that only 70,000 IOs, just 70% or 30% less, is actually needed to get the work done. And Howard, also how it writes is how it reads. So you get a lot of inefficiency, a lot of efficiencies added in that way as well. So Howard, I think unless you had anything else to add on the IntelliWrite engine, why don't we hop over to the IntelliMemory engine?
Sounds good.
Okay, so guys, this is the second Windows hack. And Howard, you're doing such a great job. Let me have you take it away again here.
So what we've discovered in real-world analysis of thousands and thousands and thousands of servers over the years is that most systems are built out and have an abundance of unused free memory. So as I mentioned earlier, that memory is really not helpful in any way, shape, or form. It's just there in case you might need it. But when it's not being used, it's a free resource that if we can tap into that and borrow a portion of that memory and be able to detect what data blocks are your applications reading from most frequently, most repetitively, that if we could get those out of the way and satisfy those directly from memory, you kind of have two major phenomena that occur here. One, because we've established a tier 0 cache with that data, the data that you're accessing most frequently is being served up directly from memory. Memory to memory data transfers are 12 to 15 times faster than going to SSD or even faster than going to flash. And on top of that, since those IOs never had to be sent to storage, those reads now are not competing for IO bandwidth. So all the other IOs, those writes that we're not caching, any writes, those writes and non-repetitive reads that are being sent to storage, they have less competing IO traffic to deal with. So it's a very significant way of improving the behavior of Windows so Windows can do a better job of managing the IO traffic before it's even sent down to storage. And if you think about it here, here's a great little visual that I like to show. And this points out how we're able to dynamically adjust the memory usage. So only we're using the free and available memory, as I mentioned, that would simply be idle and unused anyway. And our approach is intelligent enough to recognize when there is a demand for memory for other applications, for Windows and so forth, and release memory from our cache. So there's never going to be a shortfall of free memory, keeping Windows and other applications quite happy.
Thank you very much, Howard, for covering that. And just a quick note on this, and we've just got a couple slides left and we'll be wrapping up. If anyone does have Q&A, please drop it in the box now, because if there aren't any questions in the box when we get to the last slide, we'll go ahead and end off the session. Just a couple more minutes and we'll be wrapping up. And so just a quick note to add on to what Howard was just saying too, is that we talked about the 30% IO reduction that we get from the transformation of IO on the write engine. This DRAM read caching, this tier 0 strategy, will offload another 20 to 30% of all of the read IO by serving it directly from the VM, eliminating that traffic from having to go down the stack, just speeding everything up like we talked about. So real quick, I'm not going to spend much time on this, just a quick document from VMware, actually. This is their performance recommendations. They've got two recommendations. Again, you'll get the slide deck. I'm not going to stay long enough for you to read it, but the first is to increase the virtual machine memory to, in theory, allow the Windows OS to do more caching, which is, we all know, not going to happen. You've already got plenty of memory sitting there. So our engine is going to come in and do that recommendation and offload that IO. The second one is defragment the file systems on all guests. Well, we also know we're not going to do that. In fact, defragmentation is even turned off in the Windows operating system, so you don't get defragmentation IO storms in heavily virtualized environments. Our software completely eliminates the need to even think about defragmenting. If you think about what we've been talking about in the write optimization, that first Windows hack of the IntelliWrite, what we're basically doing with that engine is, if you think of a file as an egg sitting on a wall and it falls and crashes and breaks and it's all this work to put it back together again, we simply don't let that file, or AKA that egg, fall and break in the first place. We keep it all together on the original write. So it's very, very intuitive and proactive. So we're meeting both of these VMworld recommendations for best performance practices in a very enterprise and accelerated and advanced way. And this is what our UI looks like. We can walk you through this when you do your proof of concept. We also have a centralized management console that you're going to get sent a lot of reporting out of. It is a .msi file. If for VDI specifically, you can put it right into the gold image. It is also fantastic on non-persistent VDI environments. So that is our presentation today. I want to thank everyone for attending and sticking through both the executive and the technical portions. One of our team members will be reaching out to you both via email and telephone to set up your free consultations, about a 10 to 15 minute call, to see if your environment even is a good candidate. And if it is, we will be more than happy to help you with the free proof of concept. And thank you very much, Howard. Really appreciate it. You gave us a lot of great information today.
All righty. Thank you very much, everyone. Have a pleasant afternoon.